Is the following the graph of a function? So I see we've got two pieces. If it is a function, it would have to be one of those piecewise functions. Okay? But let's look at it a bit more carefully. Now, for graphs, is there a way to recognize that we're looking at the visualization of a function? Absolutely. We want to use what's called the vertical line test. Draw vertical lines. Okay. And if every single vertical line that you draw hits the curve at most 1, so 0 or 1, at most 1 point, okay, so each of these are hitting exactly once, okay, intersecting at most 1 point, then you are looking at the graph of a function. Okay? But let's draw attention to what's going on right here. And remember that when we're dealing with sort of piecewise graphs broken into pieces, okay, we often run into closed circles and open circles. It's important to remember that a closed circle represents that, yes, this point is on the graph, whereas an open circle represents that, no, this point isn't on the graph, but the rest of the graph gets as close, the rest of the curve can get as close to this point as we like, but doesn't actually exist at this point. Okay? It misses it. It goes somewhere else. It vanishes, it doesn't exist, or the curve has jumped somewhere else and you'll see a closed dot. Okay? So now, keeping that in mind, it always bears repeating because it's something people do forget. If I draw a vertical line here, okay, it's going to hit both of these. This vertical line intersects the curve at 2 points. Okay? If one of them was open, we wouldn't have this problem. If both of them were open, we wouldn't have this problem. But since they were closed, and the closed dots say, yes, this point is on the curve, then this vertical line intersects at 2 points on our curve. It fails the vertical line test, so no, this is not the graph of a function.